hi guys, hi everyone. I think that we can just wait for 1 or 2 more minutes before we start, just to make sure that everybody joins on time, and then we can just start with the Arduino session. So let's start with a skill session today. Um, First, let me welcome all of you and thank you for attending this Arduino first skill session. This is going to be a basic introductory skill session where basically you're going to be exposed to what is Arduino and just a few components of it and what it can be implemented on, and a pretty simple example at the end just to get you familiar with Arduino. But before we jump into the topics, let me introduce myself. I'm Karen Reyes. I am a TA in EPICS. This is my second semester as a TA on EPICS, and I am a master's student in the electrical engineering department. So as part of my undergrad, I fulfill plenty of projects, including Arduino, and that's where my background comes from, and being able comfortable to teach you and to show you how Arduino works, and just give you a brief overview for you. So I will jump up to the topics, and we're going to start first with what is a microcontroller. And a microcontroller is a small computer on a single integrated circuit, which has a processor core, a memory, and a programmable input-output peripherals. So we can think as a microcontroller, just a small computer. And actually, our computer has a lot of microcontrollers. So that's one way to relate it. Microcontrollers are used in a lot of automatically controlled products and devices by now. So we can find microcontrollers all around in our spaces, such as computers, as I said before, all the automotive engine control systems, implantable medical devices, remote controls, office machines, and even in toys, it's very common to see microcontrollers. So an Arduino is a microcontroller, but why are we choosing Arduino to study? Why don't we choose? Because in the market there's many other types and kinds of microcontrollers. So why we are using Arduino this time? Well, there are a few good points to use Arduino. That's what most of the students, they are first introduced to Arduino as a platform. And it's because it's easy to use, and it works with all platforms, meaning that if you have Windows computer or if you have an iOS computer, that Arduino is all going to work with both. It is cheap, so if you get a little bit of interest on Arduino and you want to keep building your own products and your own projects, you can actually find really cheap Arduino boards in the market. I was checking, and they can go from $7 to $14 depending on the Arduino that you want to get and depending on the characteristics that you want to add to it. And Arduino, it's an open source, and this is very important on the development of Arduino, because an open source means that all the this is free to get from the internet, and there are many codes, thousands of codes in the internet already that people have developed, and you can use them. And today we're just going to do an example of that, so you get familiar with what I am talking about. But if you want to construct the skateboards that we see outside in campus that people are riding around, and you will need a microcontroller to run that skateboard. And you don't have an idea how to start programming. However, those codes to make run a skateboard, you can find it already in the internet. And they are open sources, so you can just copy and paste, and you won't have to pay for anything. Neither you will have to cite who you got it from. So that's one of the reasons why we're using Arduino. And Arduino, it's composed of two parts. The first part is the hardware. So we're going to talk a little bit of this hardware. We are seeing right now an Arduino Uno board, and what I have been talking before, this big box this big black box is the microcontroller. So this is the small computer that I'm talking about. This is where all the calculations are done, and all of the other part of the board are just connections for so it can be more user friendly. So all of the magic is happening on this black box, and then all the other little pins that you see in the side and in the bottom and in the front, those are just connections to make your life easier at the time when you use Arduino. But what are all these connections? So let me explain a little bit about this. Of course, we have a microcontroller, and we need this microcontroller to make it function, and it will need electricity, of course. This electricity comes from two different powers. The first one, it can come for the USB port that is connected from your computer, or the second one is an external power supply, that it can be a battery or just the power supplies that we have in lab, or anything that can supply some energy. Then we do have the pin buttons over here where you can do the connections. And we have this called digital ground, which is just a ground. And we have inputs that are inputs or output pins, and they are called digitals. That means that all this side is just sending or receiving information in ones and zeros, or truths or falses, or highs and lows. That's what it means when I'm talking about digital. So digital means two different answers to that. It means 1 and 0, meaning 1 true and 0 false, or it can be, as I said, true or false, or high and low. Or that's the only answers, or that's the only thing that is coming out and coming in from these ports that you can see. And then in the other side, we have this power voltages pin that it can supply to 3.3 volt powers or 5 volt powers, and it depends on the project that you're using. So you can energize any external source with any external electrical components with these 3.3 volts or these 5 volts power. So you can connect it directly from here to take out, so it will function as a regulator, just sending you this voltage constantly. We do have ground pins again, And then over here, we do have analog pins. Analog pins means that they are not going to be sending information just in ones and zeros. Instead, they will be able to read information in different numbers. So let's say if you want to implement a digital thermometer where you want to measure the temperature, and you have a sensor to measure temperature, this temperature is not going to be measured in ones and zeros, of course. It is going to be measured in other numbers. So that's where you can connect and your Arduino can get that information from your sensor. That's how this analog input works. That's pretty much about all of the, we do have the reset button I think that I was forgetting this reset button to explain to you in the board. And it's usually when we use this reset button when usually our board is not performing the desired code that we are sending, and it's malfunctioning. So we just press it and it resets automatically to the beginning of the code, and we can just go over again. So that's about the hardware overview. It's pretty simple as you see, but if you have more questions regarding this, especially if you are first-time user for Arduino, it's gonna get a little bit complicated for you to understand. So we will go over some exercises to make sure that you have a good understanding. So in previous sessions, we used to download Arduino to make sure that you get an exposure of that. So if you want to download Arduino for your computer, you are free to do it. You just can Google Arduino, or here is the link to download the interface. And this moves us to the second portion of the Arduino that I was just telling you, which is the interface. So we do have the board, the Arduino Uno board, but how do we directly connect the board to the computer, and how do we talk to the board? And that's where this interface gets into place. This is, I will call it, it's just a software part that you can install. It's a program that you can install on your computer. This will help you to code, to write some lines of code, and to perform the operations that you want to do with your Arduino. Some important parts from this software is once you open the window for Arduino, you will find this verify button. And this is very important because once we write the code, we want to first check if our code is typed correctly, if we are not missing some information that Arduino cannot run. So we will first hit this button for that. Then we have the upload button. The upload button is for sending the actual code directly to the Arduino microcontroller. Then we have a new button. This is which lets us create a new window, and we can start doing a different code. We have the open, just to open if you have previously built Arduino's codes, or the save button if you want to save this code that you're working. And then finally, we have the serial monitor that it depends on the code that you're writing. It lets us read what is the output for that. In the same software, we will call it scripts. Scripts are where we are typing our code, and it will look very similar to this when you download the app, the application for your computer. And an Arduino script has two main points. The first main point is called void setup and void loop. So once you hit the new button that we were seeing in the previous slide, so let's say you hit the new button and it gives you a new window to start from fresh your code, this is what you're gonna see. It's gonna give you directly the void setup and the void loop. And what exactly these two do? So the first void setup, there goes the code to set up and to run your simulation, and it just runs once. So in this portion, it's where you are gonna specify if the pins that you're using for your Arduino are either inputs or outputs. Because remember when we were seeing the board, you just saw that, let me go back so I don't miss you all of here. So you just saw all of these digital inputs, let's say, and you said you clearly can see that they are inputs or outputs, so they can take information or they can release information. But the Arduino doesn't know what to do until you tell them what to do. So what we use this portion of the software is to do that. In the voice setup portion, that's where we are gonna say like, hey, pin 13, let's say, it's an input port. So Arduino now knows that that port is receiving information. Or you can say, hey Arduino, pin 10 is an output port. So we know now that output 10 is sending you information to an external component. And this, as I said before, this just run once. It doesn't run more than once, so it just execute this code once, and then we go to the void loop. And this void loop this is where the main code is going to happen. So this is where you're going to write everything that you want your code to do it. If you are just linking a line, turn on, off your light, that's where it's going to be just implemented here. And this runs repeatedly. So it's a loop that runs infinitely. So it will run again all your code, and then you will run it again, and then you will run it again forever. So this is pretty cool about Arduino, because you don't have to tell the Arduino that it has to be running how many times it has to run, as other, if you are familiar with using either MATLAB or C++ or even Python, when you have to tell them how many times you want to run that code. For Arduino, you don't have to do that. As long as it is in the void loop setup, you can actually run the same lines of code forever. So you don't have to implement any other artificial components here. So that's about the Arduino script. And as I said before, in previous semesters, we used to get the student, and actually like it, to get the student play a little bit with the Arduino board and implement this experiment, so you get a sense of what is exactly. And it was pretty fun because new students who doesn't have access to Arduino, who haven't had access before to Arduino, they get really excited to try this new technology or new applications. Unfortunately, today, since we are all online, I have decided that even though the skill session is still online, we are going to still play a little bit, and we are going to be using Tinkercad, that hopefully some of you are familiar with that, and if you are not, this is a good way to start learning a new tool. This is going to be a design tool where it's going to let you specifically code and implement Arduinos. It's a pretty fun and user-friendly tool. So what are we gonna do before we jump into the app? I provide you here the link, and it says join a class. You can join with this number here, and then I will give you a code for all of us, for all of you guys. Just give me 1 second so I can give you. I am populating the attendance list, so I'm able to give you a code. You will see your name on it, and then you will be able to see your nickname that is gonna ask you on the, okay. So now, let me see if I can share this part now. Okay, I think that you are able to see right now. So please check your name, and then you will see a nickname column here. You will enter that nickname into the website. So, or just write down your nickname, and then I will go over how everything is gonna work, so you don't get too confused. So, are you able to see my Excel sheet? Can somebody tell me yes or no?
Yes.
Okay, thank
I
you.
can see it.
Okay, cool. Thank you, guys. So I hope that by now you all have your nickname. So if you are twice because you join and left and join again, you have more than one number, just get the first one. It doesn't really matter. And now what are we gonna do? Let me switch my to my dashboard now. Okay, so now you are able to see this portion. So on here, and then if you go to oh, it's because I'm going into wait, let me just log out here, and then I will just Tinkercad join a class. Tinkercad join a class. You're gonna type here the class number. So the class number I will show you. It's on here. So give me 1 second. So this is where you're gonna type for your join a class. I can send you in the chat so you don't have to type it. For the ones who haven't joined as guests, you will be able to access to the code. Alexander, just one question. Are you good in the code? Because I see that you were having troubles. Alexander? Okay, cool. He's good. Okay, so if you have the code on there, and then you will hit go to my class, here is where we're just prompting to the EPICS Arduino 1 class. And here you are gonna type the number that I gave to you. So I will just type 34. That's my number. And then I said, that's me. Okay, and um, this is the website that you're gonna be prompted to. I create this way because in this fashion you won't have to create an account for yourself, so which is very useful. And now that you are here, you can do two things first. You can go to where it says it's gonna say just EPICS Arduino and the number that you choose by default, and then you can do and change your name. So I can say I'm Karen Arduino, let's say. You can just put your name, so I will know who is the person that is working on. So that's the first thing that we are gonna do. So I will wait a little bit here for you guys. Okay, hopefully you all did it. Let me know if I am going too fast or you need more time to work on it. So please let me know. Okay. So once you change your name, that you should reflect on here already. This is Tinkercad. This is a very useful tool that actually I just discovered over this quarantine period when we had a lot of trouble trying to ship students with Arduino boards and to try them to work remotely and holding skill sessions and office hours as remotely. So this is, I think it's a very useful tool. As as an instructor, I create this class so I'm able to see anything that you do in the class with the code that I just gave you. And in that way, I can provide you some feedback if you are connecting something wrong, or if you just are working on something harder later and you need my feedback also. I'm more than happy to help you with that. So what interests us from this Tinkercad is this block that it says circuits on here. So that's where we are going to click on. And then we are going to create a new circuit. And that's where we're going to hit. What it makes very helpful to this Tinkercad app is that in this side, in the right side, you are be able to see all electrical components, not just Arduino, but we will be able to see resistors, LED, push buttons, potentiometer, and batteries, breadboards, and actually here what interests us, an Arduino board, and many other electrical components, as you can see here. So over here, that's where we are going to construct, we're going to build our first project. And for our first project, as I said, this is very user friendly. So it's all about clicking and click and drag to the main board, which is over here. So we will need an Arduino Uno. I'm just pulling over one Arduino Uno. We will need a breadboard for our project. So just set it on there. We will need a resistor. We will put in there. And then we will need a LED. That is going to be also there. That's pretty much what we need. And one thing to notice from this Tinkercad is that the Arduino board that we are able to see here is exactly the same that I was explaining to you in the PowerPoint slide. So it looks exactly as the real one. We have here the USB port that it seems like you are connecting from your computer to the board. We have the pins, all the digital pins. We have the other pins with the power supplies and the analog pins. We have the actual microcontroller, and we have our extra source of power source that we don't need it on this side. And then same here for our board. This is a breadboard, our LED, and our resistor. So for people who are not related with what is a breadboard, this white board that we're seeing, I will explain you very brief. We use this to connect all the electrical components on this one. For these electrical components, it's very, if you click it on top of that, you will see that in vertical, they all connected. So if you connect something here, let's say you put a battery with 5 volts, that means that all this line is going to have 5 volts. But notice that it's just up to here, and this other side is not energized. In the other hand, if you connect here in this corner, it will energize all in vertical. Oh, that's horizontal, I think. Yeah, sorry about that. In this horizontal line, all of it. And same will happen for this plus sign, all horizontal. This part is vertical, these ones are horizontal. So if you're energized here, you will expect, if you're energized 5 volts here, you will expect 5 volts on here also. And in the same happens over here. It's very important to remark that, let's say this connection, it's this part, like this row 13, it's for no means connected with 14, neither 15. So they are separated. And now we're going to start working on the actual connections. But before we jump into any connections, I want to make sure that everything is working good with you guys, so you are able to get into the project. Okay, I will take that as a yes. So the project that we're going to be working on today is just blinking a light. And we have got all the hardware required that we need. And now we are going to implement the connection. So let me first change the parameter of this resistor. The resistor that we are using right now, it gives you here in this window the resistance value, and it's giving you in kilo ohms. And is 1 kilo ohm. So we will change this just to ohms first. And over here, we're going to be using a 220 ohms resistor. And it's something fun to see here that as you change the numbers here, the color code on your resistors also change. So it's a pretty complete user software, this Tinkercad app. So now that we have ready this resistor, we are gonna drag our resistor on here, and we just can put it on line 10 like that. It doesn't really matter. If you wanna, let's say, if you want to flip this resistor, you can change it on here on the left side, and you can just move it as much as you want, depending on the position, but this is the right position that we want to use right now. And then once again, I will connect it on 10. Right, oh no, it's not connected, so it's right there. So I'm connecting here in this terminal and in this other terminal. So that's why I'm connecting. So I don't wanna, please do not connect resistors like that. That won't work. If you want to connect a resistor, you can connect it either like that, or in the case that is flipped, oh, too much. In the case that is flipped, you can actually connect it also like this. So it's up to you, however you want to connect your resistor, it doesn't really matter. So let's assume that we just do it like this. Oh, nope, sorry. Okay, good. Now we are gonna connect our LED. The LED is very important. It has two ends, and one is called the cathode, and the other one's the anode. The anode is the positive side, and the cathode the negative side, which means that the cathode is gonna be connected to the resistor. So we will drag our LED and connect it over here. And remember that all this line is energized. So wherever I connect the resistor here, it's connected to my LED number. And this is pretty fun. You can change the color of your LED. If you click on your LED, you will see that you can change it to the color that you want. So I will just keep it on red. And now the actual connections. The actual connections are pretty easy to follow for this one. So first, we're gonna click on this portion of the positive of our LED and drag a cable all the way to our Arduino board to number 13. And it will look like that. And we can actually change the color for wires. So let's say that this is a red wire. So we will know that this is going to the red LED. Then we need to connect also this part of the resistor. So we will click also on here, drag it all the way, and this one is gonna connect to the ground. I'm sorry, my lines are all fuzzy here. Like, you can just move them around and make them look prettier. You want that. And that's pretty much what we are doing with our circuit. So it's a very simple circuit, but it is just to demonstrate how you can implement this Tinkercad. So let's see if it is working. And how do we do that? So well, remember that before when I was showing you how Arduino software works, this Tinkercad also provides you with the Arduino code. So you can click it here on code where it says. And for beginners, we have this block kind of programming part that it's pretty easy to follow. However, our interest, if we click this drop-down menu, our interest is in text. So if we click in text, and then we will just hit continue, that's where we are gonna be seeing our actual lines of code. And it's, as I said before, it's exactly as we were experiencing on the, when I was explaining on the presentation. We will see our void setup, and we will see our void loop. What it makes it easier for this Arduino is that actually it recognized what we did, and it immediately gave us the code. So in the void setup, remember that I said that it's where you are going to specify which pin is an input or an output. So we are connected pin 13 to our LED. The LED is an output because the LED is giving you to us a response. So since there is an output, we want to set up in the void setup that pin 13, as it says here, is an output. And we just write it down in this fashion. So we will call pin mode 13 output. While in the void loop, we will actually execute the code what we want to make this to do. So the first thing is that what I said when I was explaining what this Arduino does is that all these pins are digital. So for that reason, we are using this built-in function from Arduino that is called digital write. And inside of the digital write, we are telling what to do to this port. So we're saying digital write port pin 13 is going to be high, meaning that it's going to be on. For how long it is going to be on? For 1,000 seconds. And then we are going to once again say digital write pin 13 is going to be low. In other words, it's going to be off. For how long? 1,000 seconds. So that is when it happened. Hopefully you understand these little lines of code, these few lines of code, and then we can just hit a start simulation. And what we are going to be able to see in the LED is that the LED is going to start blinking. For 1 second it's going to be on, and for 1 second it's going to be off. So we just run the simulation. As you can see, our LED is running on and off. And then you can stop the simulation anytime that you want. And I just want to make sure that you are also working on it. So let me know if you are having difficulties with that or something like that. So I will give you like 2 minutes if you can implement that. In the meantime, since I sent you the codes, I'm able to see who is working on the project right now. So it's going to help me. Just jump up if you have any questions. I see that Lauren has a blank model. Are you good with that working on there? Check that Vicent is working on their board also. Ooh. What's this? I think that you're having some trouble, Alex. Are you having some trouble, or were you able to fix the problem? Okay, I just say it's cool. Okay, guys, thank you for your feedback on the on you on the chat. I know that the people who join as guests, they are not able to see the chat. Mm-hmm. Thanks for that hands up. Do you have question or is just a hands up that it's working? Okay, so let's keep moving forward. Since let me know if somebody needs more time. Okay, cool. I don't think that nobody needs more time. So let's move to the last portion of this presentation. Let me just charge my PowerPoint. And now our last portion is variables. So for a variable, it's a way of naming and storing a value for later use by the program. And remember that before in the program we were using just number 13 as the pin number, but this pin number can actually be, we can be giving it a name, meaning that we will be declaring variables, giving the type, the name, and giving the initial value, meaning that the initial value is the initial pin that we are assigning to. How we're going to be doing that is, as I said, we add the type, what is going to be an integer, because we are just expecting ones and zeros. We are going to give the variable name. You can name it anything that you want. And that's going to be equal to the port number that you're using. So in this case, it's going to be 13 if you're connecting to 13. And then the only difference that is instead of using the number 13 when we were using the pin mode, you are going to add the name of the variable. So that's how variables work. That's how we create them. And then we are going to just continue with the project. So before, by default, we have port 13. Now I want you to change that port 13 to port 2, but we want to create a new variable. Instead of just using the number 2, I want you to create a variable of type integer. We are going to give the name green or red, or any name that you want to give it. And it's going to be equal to what exactly? And now we want to make sure that the code is still working. So let me do that for you. So let me point out this over here. And I'm just going to do the first portion. So it says, we don't want this no more. So let me make some space here. We are going to create a variable that is type integer. We are going to call it red. And this red is going to be equal to 2 now, or any number that you want from the pins. Now, instead of this 13, we are going to replace by the name of the new variable that is called red. And everywhere where it's 13, we are going to call it red. And once again, red. And yeah, our code should run, right? If I press start simulation, of course, our light is not blinking. Somebody can tell me why? Okay, I noticed that everybody's shy today. So it's not blinking because we haven't changed our port number. Our red wire has to be changed from 13 to number 2. How do we do that? It's pretty easy. We just stop the simulation. We can delete the whole wire by just clicking on it and pressing delete. And then we will wire it again. This way, having from the positive all the way to here, and then we are using just port number 2. I will just change my color of my wire just to make sure that it's color code and we don't get confused with the wires. And then we can run the simulation. And once again, yes, my light is gonna be blinking. So once again, I will give you a couple minutes for you to work on that, and just give me a heads up if you are already done with that. It's a pretty simple thing to do. And I really hope that is a better way to interact all of us together. So hopefully you are all having fun. Thank you, Wumin. Thank you for the feedback. Yeah, I think that Tinkercad is very useful. And usually it lets you interact with other teammates. So as I said, I am able to see what you're working on. So I can provide you some feedback. If it is a bigger project, that's very useful because it helps you to interact with your teammates. And you don't have to be in the same room to be working on the same project. So I think that this is a very useful tool that you can just implement on your projects. Okay, so we will wait just a couple more minutes for everybody to finish. Thank you, Christy. I saw that you completed. And just in the meantime, while everybody's working on this small project, this Tinkercad, it doesn't just help for Arduino. It does have different tools for, especially for 3D modeling. So if you have some time, your spare time, you can actually take a look of it. And I think it's an awesome tool. Plus it is free. I'm not promoting it, but it's just free. And I think that for a student, it's very useful to learn these kind of tools, especially now that in the market, everything is evolving, and especially with this online situation that we live in. Oh, nice, Ravina. I like your blue LED. That's good that you changed your color. Okay, I think that everybody has done by now. So for the last portion that we want to do here, is that we want to create now Okay, is this. Now we want to blink two different lights. But this light has to be blinking alternatively. So meaning that you are going to connect now two lights, one red and one green, and you are going to make them blink first red, green, red, green, red, green. So and alternatively, one and then the other one. So how can we do that? We have to connect the two LEDs first, and they have to blink alternatively first. And how many variables should we declare now? Should we list? How many variables do you think that we should list now? Should the type still be integer? And then, of course, you can give them any name that you want. And they will be equal to, what do you think it should be equal to? So I won't do this experiment. I will leave that board for you to do it, and I will be just here checking your projects in the meantime while you hear me talking about it. So yeah, I know that this session is very introductory. It's the means that it's just 1 hour session. So I try to cover just the introductory part. Oh, nice. I don't know the name because, oh yeah, no, I don't know the name of this person. Who is EPICS 24? That's nice. Thank you for adding more push buttons and everything that you know in Arduino. I see the circuit that you have developed. Oh, thank you, Brendan. Oh, really? Didn't? That's shame. Yeah, you can just keep working on that, or you can just create a new account if you want to work in your free time on these kind of materials. Rahul, I just saw that you haven't done anything. Were you having troubles with that? Oh, so probably it doesn't just update for me. Thank you for answering. Let me see Arduino 23. What is this person? Okay, I see you're working. You got one LED working on there. Just one step closer to what we have to do. Cody, is yours working? Well, I see that you're missing several parts. So you are missing a resistor. I see that your green LED, it's missing a resistor as well as, so copy exactly the same connection as the red one. And then you also need to modify your code. So you are just making it work for the red one. So remember, it's really good that you add the two variables. However, you still need to add more code in the while loop. So this one is for the people who haven't get into Arduino in their lifetimes. Something is challenging. Of course, for the people who have been working on it already, it's pretty easy. And then Ravina, I see that you're doing a good job. However, you're still missing just one extra wire for your resistor. And I don't know if you have changed the values of your resistors. Remember that we're using resistors of 220 ohms. I see that Zach is working. Good job. So now we are getting at the end of our skill session. Let me just pull out once again the template here. So I want to give you just a big thank you for all of you who have been attending to my skill session. Hopefully it has been some insight points that is helpful for you to get into the program. If you have questions about Arduino, about the project that you're implementing, if you are working on something, you are free to contact me anytime. I do have office hours on Tuesdays and Wednesdays after 4:30. And you can just send me an email to kreyespa@purdue.edu and just schedule a meeting with me if you have questions regarding Arduino. Also, I know that this session has covered this Tinkercad app where everything is just a software-based program. However, if you actually need an Arduino to try out the same experiment that we just did in software, you want to actually have the experience touching the Arduino and assembling the kits and assembling with the wires, and you gotta have an exposure of that, you can contact me, send me an email. I will be more than happy to provide you with the instruments, with all the tools for you to use. And actually, we can just go in a meeting one-on-one to go over basic stuff if Arduino has developed this inquietude in you to learn a little bit more or to develop something that you, or if you have a problem, a project that you have been developing and you want some help with that. I am the person to contact too. I just want to give you a big thank you for attending the Arduino skills session, and hopefully I will see you in the other Arduino sessions also. And just don't hesitate once again to contact me if you need me. I think that's it for today. Hopefully you all have fun, and at least hopefully today you learned something new. So goodbye, guys.